Okay, so let us now start studying free fall problems. Now, by free fall, we mean falling under the influence of gravity, so something that's just simply dropping. And what we'll do is we will ignore the effects of air resistance, so no drag will be considered, and we'll say that it is falling simply because of the pull of the earth and the object. Okay, what we know is that close to the surface of the earth, the acceleration due to gravity has a value of 9.8 meters per second square, and it's pointing vertically downward. Okay, so remember that when you put it in your charts, okay, the A will have a value of negative 9.8 meters per second square, and then also while we're dealing with these, vertical falls and rises and all that, keep in mind that the signs of the displacements and the velocities will also have to be adjusted depending on whether something's going down or up. Be very careful. Alright, so let's start a problem, and let's say that we're going to determine the time required for a ball to drop to the ground if released from rest from a height of 1 meter. Let's make it 4 meters instead. Okay, so we're going to drop something from a height of 4 meters, and we want to know how long it's going to take. So the steps are going to be once again the same. We can apply all our 5 equations because this is motion with a constant acceleration. So let us make our chart. I hope at this time that you have actually tried the problem and that you have some solution, some answer, and you're going to verify. Alright, so we have all this. Let's plug in delta x. What is delta x? And this is what causes the most problems for people. Remember, the object is falling down, which means delta x is equal to negative 4 meters, and the negative implies the direction of going down. Okay, Vi is 0 because we are releasing it from rest. Vf we do not know, and A is negative 9.8 meters per second square. This, although the 9.8 meters per second square is not given directly in the problem, but as soon as you know something's free falling, we can assume that. A common mistake that people make is that they assume that this is equal to 0. So do not assume equal to 0. Okay, because then you'll be telling me that if something's released, okay, it's going to stop just before it hits the ground, and I don't think that we all know that doesn't happen. So please be very careful about that. Alright, now that we have all this, we're asking for the time, and so we do not care about Vf, and clearly we're going to use equation 3. So use delta x equals Vi delta t plus 1/2 A delta t square. And when I plug everything into here, this equation implies negative 4 equals 0 times time minus 4.9 delta t square. Perfect. Now at this point the algebra becomes very easy. This term basically just goes away. So we have minus 4 equals minus 4.9 delta t square. And I get delta t square equals 4 divided by 4.9. And this happens to be